Alright, time to do section 2.1, derivative rules. Remember that these rules come from doing the limit of the difference quotient. People had to work very hard to uncover what these rules should be. Alright, here we are told that h of x is this sum of two functions, f and g, and that f of x is 7x to the 5th, while g of x is 9x to the 4th. They want to know h prime. So f of x was 7x to the 5th, and g of x is 9x to the 4th. You can differentiate term by term. So you just take the derivative of this one. You get 7 times 5x to the 5 minus 1. And then the other one is 9 times 4x to the 4 minus 1. Simplify this and you have 35x to the 4th plus 36x cubed. And you just type that in, but don't include the h prime. Absolutely include the h prime if you are on a written exam, but here in the homework, they're just wanting the function, the rule. That one actually used two rules because you had to use the fact that the derivative of a constant times a function is just the derivative, is just the constant times the derivative of that function. All right, here we have that we need to find g prime of 9 given this stuff here. So g of x is a minus 2 times f of x, and f prime of 9 is minus 8. So it looks like this. And then g prime of x would be equal to a minus 2 times f prime of x. And we are wanting to know g prime of 9, so that would have to be minus 2 times f prime of 9. And we know f prime of 9, it's minus 8. So this is a minus 2 times a minus 8. You get 16. All right, it's not so bad. Super. Mastery 13%. Okay, it's not too far off. But there might be multiple objectives. We'll see. Here's another sum of two functions. They've defined h of x to be f of x plus g of x. So then h of x looks like 8x to the 7th plus 4x to the 5th. And they want us to find h prime. Then you may differentiate term by term. This would be 8 times 7x to the 7 minus 1 plus 4 times 5x to the 5 minus 1. Of course, you don't have to make all that writing if you kind of, get the hang of it. I'm just doing it for now because we are just starting out. So we get 56 x to the 6th plus 20 x to the 4th. All right. Awesome. Here's one that's 9 times f of x. That's what g is. So then g prime has got to be 9 times f prime. G prime has got to be 9 times F prime, because G was exactly 9 times F. You know, the behind the scenes stuff is that G prime, okay, that means we want to differentiate with respect to x the function g, and g was just 9 times f of x. It's this function, 9 times f of x, but constants can come out front, so you're just differentiating f of x, which would be known as f prime. So it's just 9 times f prime of x. And they want us to evaluate it at 2, and f prime of 2 is just 3. So g prime of 2 would be 9 times f prime of 2, and f prime of 2 was 3. So this is 9 times 3, you get 27. All right. Here, I bet we can do this one without even having to write anything down. Right? G prime is just going to be minus 8 times f prime. And so g prime of minus 3 is going to have to be minus 8 times f prime of 3. F prime of 3 is minus 10. So g prime of 3 would be minus 8 times minus 10. That's 80. Here's another one like that. 6 times f of x, so the derivative is 6 times f prime of x. They want it evaluated at minus 9. The derivative of f there is minus 4. So it's 6 times minus 4. You get minus 24. So you should be cooking if you get some questions like that. They're not too bad. Here is a function h that's defined by the sum of two other functions. So h of x is just x to the 5th plus 3x. They want h prime. You would have 5x to the 4th plus 3. Right? Because the exponent there is 1. The 1 comes down, and then it's x to the 1 minus 1. That's x to the 0. And surely you remember x to the 0 is the number 1. So this would just be 3. Alternately, that says 3x is just the equation of a line whose slope is 3. And so any tangent line to this linear function, y equals 3x, would also necessarily be this same equation. So then its slope would definitely have to be 3. The derivative of a linear function is the slope. The slope of a line is its instantaneous rate of change for every x value. Alright, so what were we getting? 5x to the 4th plus 3. This one's f minus g. So h of x is 9x squared minus 8x. Well, that's not really going to trick us. We do need to pay attention here that they want to know h prime of negative 5. Okay, well, h prime of x is 18x minus 8. And then now they want to know h prime at minus 5, that's just 18 times minus 5, and then minus 8. So this would be a minus 90. Minus 8, you get minus 98. Super duper. Alright, let's keep it moving. Get out of the way, you guy. Find the equation of the tangent line to the function, and it's this cubic function, at the point where x equals 1. And our function is minus 3x cubed minus 2x squared minus 1. That's a cute function. That looks like some cute nonsense that I would do because really, well, I guess it's not exactly cute. The cute thing I would do would have it be x to the 1, and then everything, then all the exponents match the coefficients, but they didn't do that. They gave us this, and they want to know the equation of the tangent line when x is minus 1. Okay, to do that I need f prime of x. F prime of x is minus 9x squared minus 4x. Awesome. Then f prime at minus 1 tells me the slope of the tangent line when x is minus 1. So that's minus 9 times a minus 1 squared, so it's 1, and then minus 4 times minus 1, so that's plus 4. You get minus 9 plus 4, that's minus 5. So the slope of the tangent line is minus 5, and that's the tangent line when x is minus 1. But I still need to know what the point that the line goes through is, because right now all I know about the point that that tangent line goes through is that it's minus 1 comma who knows. All I know is that it's f of minus 1, but I can't be lazy. I have to actually figure out what f of minus 1 is. Okay, so that's going to be 3 minus 2 minus 1. 3 minus 2 minus 1, that's 0. All right. Well, I know that an equation of a line is y equals mx plus b, and this point has the format x comma y, so then 0 has got to equal a minus 5. Where did the minus 5 come from? Right there. Minus 5 times x plus b. Now you could solve it for b. Evidently, b is equal to 5. I mean negative 5, sorry. Then the equation of the line would be y equals minus 5x minus 5. You should take the time to graph it. Head over to a site like Desmos and graph that guy and be amazed at how your curve exactly touches this line at the point you prescribed. Determine all the values, or determine the values of x for which this thing has a horizontal tangent line. Oh, geez. There aren't any. This function is a line. And that line does not have a slope of 0. It's not going to have a horizontal tangent anywhere. Find the equation of the tangent line to the function at the point where x is minus 1. All right. Let me write down our function. It is 2x cubed plus 3x squared plus 4x plus 2. Come on, y'all. They could have said like plus 5. Oh well. And they want to know what's happening when x is minus 1. I need f prime. F prime is 6x squared plus 6x plus 4. F prime evaluated at minus 1 will be 6 minus 6 plus 4. Well, that's easy. That's just 4. This is the slope of my tangent line when x is minus 1. If x was some other number, obviously I'd get a different slope. It remains for me to see what is f of minus 1. Then, well, check it. This would be a minus 2 plus 3 minus 4 plus 2. So that's minus 1. Now, in general, your tangent line, I can write down the equation of the tangent line for any function at all. Ready? The tangent line always is y minus, well, let me say it like this. The tangent line for x equals minus 1 is always y minus f of minus 1 equal to f prime at minus 1 times x minus minus 1. But there was really nothing special about our minus 1. It could have just been this number a. And then look at this beauty here. That, y'all, is the equation of the tangent line for whatever number you are talking about every time. Every time. Okay, well, I'm wanting to do it for minus 1, so let me quit messing around. I know that f of minus 1 was minus 1, right? So this would be y minus a minus 1, that's y plus 1. And then f prime of minus 1 was 4, and then this would be x plus 1. So I get 4x plus 4. Y plus 1 equals 4x plus 4. It must be the case then that y is equal to 4x plus 3. You didn't have to do it like this. It just works every single time. If that seems awfully too much trouble for you, then by all means fall back on what you know and just say that what I know is that a line has the form y equals mx plus b. And you already found out what m was. It was 4. And you know what one of the points is that this line goes through. You have the x and the y coordinates. So you put in those x and y coordinates. And then you can solve for b. Right? This says -1 equals to -4 plus b. So you add 4 to both sides, you get that b is equal to 3. Look at that there. That says b is 3. So my line is y equals 4x plus 3. Come on. It's this one. Oh boy, what are they doing to me here? Find all the values of x at which this function has a horizontal tangent line. And the function they gave me is 7/3 x cubed plus 3x squared minus x plus 9. I'm supposed to give all the x values separated by commas. Okay. Here's my function. F prime of x is going to be 7x squared plus 6x minus 1. I am curious where this thing is equal to 0. Okay. That means you're going to have to factor this function. Unfortunately, y'all. That is, unless you can recognize what a root would be. If you can recognize what one of the roots would be, then you can divide using synthetic division. Because I can see right away that if x is -1, then this equation would be true. Because it would just say 7 minus 6 minus 1. So then -1 is a root. That means that it will divide by x plus 1 readily. And I could do my synthetic division and know what that other term really is. -1 times 7 is -7. You add those together, you get -1. -1 times 1 is 1. Add those together, you get 0. So this thing factors like 7x minus 1 times x plus 1. Okay, maybe you're just really good at factoring and knew that that's how it would work out. There is another strategy to factor that, and that would be to take this number times this number, which is -7, and then get this number coefficient here in the middle, and then try and solve this system. Solving this system is always easier, or most every time easier, than factoring the polynomial or factoring the quadratic. And all you gotta do is find an a and a b for which this works, and you can do that just by looking at the sum. So I mean, how about 3 plus 3? 3 plus 3 is 6, but 3 times 3 is 9. That's a positive number. I need the product to be a negative number, so I'm going to have to do stuff like, oh, I don't know, 1, or how about, 7 minus 1. 7 minus 1 is 6, and 7 times -1 is -7. So I know that A is 7, and B is -1. Well, then I could disassemble this quadratic and make it say 7x squared plus 7x minus x minus 1. all I did was rewrite the middle term using my A and B. And then you factor by grouping. So you can factor out a 7x and you're left with x plus 1, and then you factor out a minus 1 and you're left with x plus 1. Then they both have an x plus 1, and what's left over is 7x minus 1. Either way, you have the factorization of this here guy, and now you know all of the places where the derivative is equal to 0. Evidently that happens when x is minus 1 and when x is 1/7. So our answers will be minus 1 and 1/7. Okay. Terrific. This is probably not an assignment that you want to be missing a bunch of problems on. It sure does seem like this would be the one where you miss a bunch in a row, and then before you know it, you have a homework assignment that's 100 problems long. Excuse me. Find the equation of the tangent line to this function when x is minus 2. Okie dokie. F of x is x cubed plus 3x squared plus x plus 4. And they're curious about when x is minus 2. So at some point I'm going to need f of minus 2. Let me just get it now. That will be minus 2 quantity cubed plus 3 times minus 2 quantity squared minus 2 plus 4. So we wind up with negative 8 plus 12 minus 2 plus 4. Right on. So that's a minus 4 plus 10, you get 6. So our line, our tangent line, is going to go through the point minus 2 comma 6. Keep that there, that's going to be handy. Now it's time for the derivative. I know, Simon. I need to take the derivative. You hear my cat? Come here, buddy. Come here. Come here. F prime of x is going to be 3x squared plus 6x plus 1. Not too bad. F prime of negative 2 is going to be 3 times 4 plus 6 times negative 2 plus 1. So that's 12 minus 12 plus 1. This is just 1. That's the slope of my tangent line. So the equation of my tangent line is going to be y equals mx plus b. M is 1. I know, Simon. We're going to bed in a minute. This point has the form x comma y. So this would have to be 6 equals to minus 2 plus b. Evidently then, b is just 8. So our line is y equals x plus 8. That is in mx plus b form. Let's type it in. Y equals x plus 8. Getting close on that mastery. I hope it's like end of the assignment when that bar reaches completion. Here's another one. I believe I remember telling you all that there was a lot of these where it's find the equation of the tangent line. Simon, chill out, buddy. He is beating up that chirping bird toy. F of x is minus x squared minus 3x plus 4. He does not like it when we stay up late. If I'm up past the usual bedtime, he flips out and starts hollering at me like he's doing right now. So we are going to need f of minus 3. We are going to need f prime of x, and then we are going to need f prime of minus 3. Okay. F of minus 3 is minus 9 plus 9 plus 4. These are really highly engineered to have that cancellation. Good. I'd probably mess up if it was too hard. Then f prime of x is minus 2x minus 3. Okay. F prime of minus 3 is minus 2 times minus 3, and then minus 3. So you get 6 minus 3. That's 3. You know that lines in slope-intercept form look like this, but B is what you won't know. In fact, let me rewrite this. This is the same thing as saying f of a is equal to f prime of a times a plus this number b. And b is what you are looking for. And a is this guy. Minus 3. That's what we evaluated these things at, was minus 3. So you could just always have this equation handy. B is just always going to equal to f of a minus f prime of a times a. Or I like it better like this. We'll say a times f prime of a. Here's your formula for B. Stick it up and fold it up and stick it in your pocket. What B am I talking about? That one. And here A is just minus 3. It's the same number I've been sticking in all these other functions. So, and look, f prime of minus 3 I've already got. It's 4. And A was minus 3. And f prime of a was 3. So B has to be 4 plus 9. That's 13. So my function, my tangent line, looks like y equals to 3x plus 13. Y equals to 3x x plus 13. Find all the places where the tangent line is horizontal. Well, our function is 25/3 x cubed plus 10x squared plus 4x minus 7. F prime of x is 25x squared plus 20x plus 4. And I wonder where that guy is equal to 0. where does 0 equal to 25x squared plus 20x plus 4? And off the top of my head, I don't recognize right away what x would be that would cause that equation to be true. So I have to fall back on my my method from earlier. I get the sensation that this thing is some kind of perfect square, but we'll see. I need an a times a b that equals 25 times 4. 25 times 4 is 100. I need an a plus a b that equals to 20. Well, gee whiz, I see it right off the bat, because 10 plus 10 is 20, whereas 10 times 10 is 100. So a is 10 and b is 10. Since a is 10 and b is 10, I can rewrite this here quadratic as 25x squared plus 10x plus 10x plus 4, and then factor by grouping. I can factor out a 5x from the first pair and be left with 5x plus 2. I can factor out a 2 from the second pair and be left with 5x plus 2, and I'll be doggoned, I was right. The 5x plus 2 is common to both terms, and what's left over? 5x plus 2. It has, it's a perfect square, so it's just 5x plus 2 squared. Then the place where this dude would equal 0 would be wherever 5x plus 2 equals 0. That's got to be a minus 2/5. You put the minus 2/5 in for x, the 5's cancel, and it says minus 2 plus 2. Okay, minus 2 over 5. Ah, 34 minutes is how much I've spent so far on this. F of x is 4x squared minus 2x plus 20. Okay. Where does it have a horizontal tangent line? F prime has got to be 8x minus 2. That's going, so then where does that equal 0? 0 equals 8x minus 2 whenever excuse me, not that simple. Whenever x is 2 over 8. 2 over 8 reduces, or simplifies, excuse me, to just be 1 over 4. You didn't see anything I was writing. I'm sorry. I wasn't paying attention. So here's my function. Here's the derivative. I set that derivative equal to 0. I'm careful to never say this. That's not true. That's not true. This is the problem. That's an improper use of the equal symbol. You're essentially saying by the transitivity of equals that f prime is 0. Don't do that. Make a new line that says, gee, now I wonder where 0 is equal to 8x minus 2. And it happens when x is 1/4. And we're done. Alright, that took me 36 and a half minutes. Don't miss too many in a row. You're going to really regret it. Schedule an appointment with me if you need help.